all substances are used up in the previous example. However, we're going to see another important concept. It is the limiting reactant. The two reactants are not all used up in the reaction. Sometimes, either one may be in excess. For example, though you'd like many things in the world, you cannot buy them all. Money is your limiting reactant, and you will not have enough money to buy them all. So, limiting reactant is the crucial factor in determining the number of products produced. Then, what is the limiting reactant? Limiting reactants must be used up, so the amount of products produced must only be related to the amount of limiting reactants. Here is a simple example using the previous case. The example of hydrogen, oxygen, and water. 2 moles of hydrogen should react with 1 mole of oxygen. However, there are 2 moles of hydrogen and 2 moles of oxygen here. So, which one is in excess? Of course, it is oxygen. It means that hydrogen is the limiting reactant. Another simple calculation is related to the reaction between 0.2 mole of hydrogen and 0.2 mole of oxygen. We should know that the ratio should be 2 to 1. But now, the ratio is 0.2 to 0.2, which is 1 to 1. In this case, oxygen is in excess because only 0.1 mole of oxygen is required in the reaction with 0.2 mole of hydrogen. So, the limiting reactant is hydrogen. We will make use of this concept in further calculations. Since oxygen is in excess, hydrogen is the limiting reactant. We just need to consider hydrogen and ignore oxygen. We know that 2 moles of water will be generated from 2 moles of hydrogen, so 0.2 mole of water will be generated from 0.2 mole of hydrogen. There is 0.2 mole of water. If we need to calculate the mass of water produced, we need to multiply number of moles of water with its molar mass, which is 0.2 times 18 equals 3.6 grams. Let's see another example. This example is slightly more complicated, but it is also simple. It is the reaction between 2 grams of hydrogen and 1.6 gram of oxygen. We have mentioned before that all numbers in gram should be converted into mole in the first step. It would be easier for further calculations. The chemical used here is the same as the previous one. First, we need to convert the mass of hydrogen and oxygen into number of moles. To repeat, you just treat mole as a number. For example, number of atoms. For hydrogen, divide its mass by its molar mass, which is divided by 2 times 1. 1 mole of oxygen is presented. Similarly, for oxygen, divide 1.6 by 2 times 16, which is 32, and we will get 0.05 mole. We can clearly know which reactant is in excess and which is limiting. The ratio in the chemical equation is 2 to 1. If the number of moles of hydrogen is 1, that of oxygen is 0.5. But if the number of moles of oxygen is 0.05, that of hydrogen is 0.1. So, which one is the limiting reactant? We know that oxygen is the limiting reactant and hydrogen is in excess. So, how can we do the calculations? We will calculate with respect to oxygen but not hydrogen. How many moles of water is produced? Since the ratio between oxygen and water is 1 to 2, so multiply 0.05 by 2 equals to 0.1. To calculate the mass of water, multiply 0.1 by 18, which is 1.8 grams. It is a simple calculation by taking the limiting reactant into account. To make things simple, First, a chemical equation is provided in this example. If not, you need to first write down a balanced equation for the question. Second, convert all numbers into the unit of mole. It will be easier for calculations if all numbers are in the unit of mole. If the number of moles is not given, but other information, such as mass, is given, just convert them into the number of moles. Then, try to find out the limiting reactant by considering their ratio. Both reactants will be used up sometimes, but more often only one of them will be used up, and the other one is the limiting reactant. We need to take limiting reactants into account in calculations. That's all for today.